Hi, Bobcats. In this video, we're going to take a look at predicting the sign associated with delta S for various processes. Sometimes without even knowing numbers, we can predict whether entropy increases or decreases just based on other information. For instance, a solid has less entropy than a gas. So we know that if something transitions from being a solid to being a gas, then the sign of delta S would be positive because we end up in a state with more entropy. So we'll be looking at some scenarios like that in this video. Our objectives include defining entropy as we look at some more facets of it, and to identify the sign of delta S. So there are certain properties that we can look at that give us some indication of the nature of the entropy of a situation. So for instance, if we are looking at the phases, solid, liquid, gas, gases have way more entropy than a solid or than a liquid would. You look at the diagrams down at the bottom, you'll see that gases have just tremendous randomness as those particles are going all over the place. In the liquid state or a condensed state, the entropy is much, much less. The particles are much closer to one another, and there are fewer possible arrangements of them. A solid has less entropy than a liquid does, but it's fairly comparable, especially when compared to how much more entropy a gas has. And then the absolute lowest amount of entropy would be found in a perfect crystal, and the colder the temperature is, then we start approaching the 0 point of entropy. At higher temperatures, we do have more entropy than at these lower temperatures, because at higher temperature, the particles are moving around more, they're more disordered. Changes in the moles of gas will also contribute to entropy. If you have some sort of a chemical reaction taking place where on the reactant side you only have solids, but on the product side you have lots of gases, then we're going to have a huge increase in entropy as that chemical reaction takes place. And then also, if we have a change in how much stuff we have, we'll have a change in entropy, because entropy is an extensive property. Extensive properties are those properties that change depending on how much stuff you have. And so if we have more stuff, we have more entropy. Students very often miss questions about sign changes associated with delta S and also delta H, the change in enthalpy, for phase changes between solid, liquid, and gas. Stick with me while we go through this diagram, and hopefully I'll be able to convince you how to answer those questions correctly every time. So think about temperature, right? The lower the temperature is, the more likely you are to have a solid. And then as you increase the temperature, you are increasing the enthalpy as well as increasing the entropy. So a liquid has more enthalpy and more entropy than a solid does. And then highest of all on this scale would be a gas. So if we're going to look at the sign of delta H and delta S for phase changes, draw yourself an enthalpy or an entropy level diagram. That vertical axis is going to track the same way, whether we label it enthalpy or entropy. If we have the transition of a solid turning into a liquid, which we would call melting, we start at a lower level on this diagram and end up at a higher level. So delta S and delta H would both be positive. If we take that liquid and we turn it into a gas, well, let's see, we call that vaporization, boiling. Both the enthalpy change and the entropy change are positive because we're getting higher on this scale. Well, what if we reverse these guys? What if we take a gas and condense it down to a liquid? Well, we're going from a high state to a low state, so the sign would be negative. And if we take that liquid and turn it into a solid, the sign would be negative as well. And again, this is true for both enthalpy and entropy changes. Well, there's one other set of phase changes we could do, and that would be for a solid to go all the way up to a gas without stopping at a liquid. We call that sublimation. So that requires an increase in energy or enthalpy and also an increase in entropy. So delta H and delta S both are positive for this one. If a gas turns into a solid without going through the liquid phase, we call that deposition, and the sign of both enthalpy changes and entropy changes will be negative for this one as well. So when you see a question about the sign of delta H or delta S for a phase change on a quiz or on a test, be sure to draw yourself this energy level diagram and look closely. If you start low and go high, that's a positive change. If you start high and go low, that's a negative change. All right, in this example, we are going to be asked to pick which system has the greater entropy. That will be given pairs. The first one is 1 mole of hydrogen gas versus 2 moles of hydrogen gas. Now, we are assuming that everything else is the same. All we've done here is doubled how much material we have. And entropy is an extensive property. So if we have more in one sample than in another sample and everything else is held constant, then the sample that has more has greater entropy. H2O solid versus H2O liquid. Well, between a solid, a liquid, and a gas, gases have the greatest entropy, liquids are next, and solids have the least. So comparing a solid and a liquid, the liquid will have the greater entropy. Iodine gas versus iodine solid. Out of the 3 states of matter, gases have the most. And let's see, 1 mole of oxygen versus 1 mole of ozone. Well, that mole of ozone has more atoms in it than the mole of oxygen does, so having those extra atoms gives ozone a little bit of an edge here. For this slide, we're asked to find the sign of delta S for a series of reactions. If delta S is positive, then entropy has increased. If delta S is negative, then entropy has decreased. So what do we have here? We have AgCl in the solid state going to dissolve to give us Ag plus ions, aqueous ions, and Cl minus aqueous ions. So in this case, entropy has increased because that dissolved state has more entropy than the solid state does. So delta S is positive. So one way we could write that is that delta S is greater than 0. Another way we could write that is just to say it's positive with a plus sign. 2 hydrogens plus oxygen yield 2 H2Os. Well, the key here is the states. We have gases on the left-hand side and we have a liquid on the right-hand side. Liquids have less entropy than gases do. So in this case, entropy is decreasing. So delta S is negative, whichever way you want to write that. And last but not least, on the left-hand side in this bottom reaction, we have 3 moles of gas. 2 of them are hydrogen sulfide and 1 of them is sulfur dioxide. On the right-hand side, we only have 2 moles of gas. That's water. The sulfurs are in the solid state, and solids have way less entropy than liquids do. So we have more moles, than gases do. We have more moles of gas on the left, fewer moles of gas on the right, so that means that entropy is decreasing. So delta S is negative, or we can put a minus sign on it. This question asks us to figure out which one of these has a decrease in entropy. Let's see, oxygen at 300 Kelvin versus oxygen at 400 Kelvin. Well, the higher the temperature, the greater the entropy. So this first one is an increase in entropy. And the next one, they're both at 25 degrees C, but we have the gas phase condensing into the aqueous phase, so we're dissolving that nitrogen in the liquid. So that looks like here entropy is decreasing because gases have the most entropy. But before we stop here, let's check out the other answers just in case. Answer C, we have solid water turning into liquid water. Liquids have more entropy, so this is an increase. In the next one, they're both at the same temperature, but we have a liquid turning into a gas. Gases have greater entropy, so that's an increase in entropy. And then we have gas phase water, two gas phase water molecules turning into two gas phase hydrogens and one gas phase oxygen. So 2 moles of gas versus 3, that is increasing as well. So going back to Sesame Street, and one of these things is not like the other, B is going to be our answer. That's the only one where entropy is decreasing. So we took a look here at how the sign of delta S can be predicted just by looking at some other things like how much stuff we have, or what the temperature is, or what the state is. And that handy dandy little trick for a test where you're asked to give the signs of delta H and delta S for phase changes, just draw yourself an energy level diagram here, right? The higher you are on this, the higher your enthalpy and the higher your entropy. So if we go from, say, a solid to a liquid, then that's a positive. But if we were to go from, say, a gas to a liquid, that's going to be a negative. And those signs apply to both enthalpy and entropy.